To kick things off, I'm Shane. I'm the founder of Evervault. We build developer for companies that need to collect, process, and share card data. So we spend a lot of time building integrations with the card networks and issuing and acquiring banks to help them both control and write their own payments, but also get rich insights from issuers and the card networks themselves. So network tokens is a pretty hot button topic for a lot of companies, and I'm excited to dig into it a bit more today. Hey, Trevor. Hey, Adolfo. One thing to flag is, as we were kind of creating the title for this webinar, realizing that it ends with a question. I think in this case, this is the exception that proves the rule, where Betteridge's law of headlines doesn't always apply. We do think network tokens are worth it, and we're going to run through a few of the reasons why, as well as some of the drawbacks of them as well. Hey, William. Hey, Douglas. So yeah, just to give you a quick overview of what we're going to run through today. In the past, we've done extensive deep dives into what network tokens are, the kind of technical details of exactly how they work and what the configuration looks like. So we're not going to spend a huge amount of time on that today. I would recommend going through our previous webinars, which you can see on our site, to learn a bit more about that. So we're assuming some level of base level understanding on what network tokens are in the first place here. And most of the focus of this webinar is going to be on, I guess, just what's the point of them? Do they actually provide value? How do they help? Some data that we've collected on issuer support, as well as how do you calculate ROI, and how should you actually go about implementing them if you decide it's something that actually makes sense for your business. So as a quick primer on network tokens, in its simplest form, a network token is basically a proxy credit card that's created by the card networks to represent a raw 16-digit card number. Basically, all of the card networks have their own separate services, which maintain token vaults, where they store a mapping of a network token, which looks and feels like a real credit card number. Typically, it's about 16 digits. Their loon checksum valid and so on. They store the mapping to the raw credit card. So both the merchant and any of the other service providers that the merchant might be using never end up actually touching the raw PAN. So part of it is security driven. The card networks are really pushing for adoption of network tokens because they reduce fraud. They're far less sensitive in the event of a data breach. And they have some interesting characteristics as well that give sophisticated merchants and also service providers a lot of configuration about how these tokens can use. So in theory, network tokens are merchant specific, where you create a network token. If you're Acme Corporation, you create a network token that in theory can only be used by Acme Corporation. That configuration is actually up to you. And in a lot of cases, people don't always implement it correctly. But you can think of network tokens as merchant-bound representations of a raw credit card number. So the issuing banks do have to enroll into network tokens. They end up connecting with the Visa token service, where they swap out the network token for a raw PAN every time a payment authorization happens. And then on the acquiring or merchant side, they can either be requested by your PSP, or they can also be requested through a standalone token service provider who's built either direct integrations with the token services from the card networks, or maybe they're going through some other third party, whether that's a PSP or a payment gateway or something similar. So the standard for network tokens is actually governed by EMVCo. Some of you are probably familiar with EMV from the initial standard that they designed many decades ago at this point for chip and PIN payments. But EMVCo is basically a kind of joint venture of all of the card networks, where they define the standards and protocols for how card payments happen. They were initially designed for Apple Pay. So this Apple Pay was the very first production deployment of network tokens, where your phone actually never stores a representation of your raw card number. And they use the EMVCo payment tokenization protocol under the hood to actually create those tokens and then work with them every time you need to either authorize them or handle lifecycle management. So even though network tokens apply in the case of both mobile wallets like Apple and Google Pay, as well as card on file tokens, we are going to be focusing a little bit more on the kind of e-commerce card on file tokens here, rather than mobile wallets, but a lot of the advantages and value prop are pretty similar. From the issuer and acquirer standpoint, they can treat them more or less the same way. And then the card networks handle all of the complexity of figuring out, is this a mobile wallet network token, or is this an e-commerce network token? So I guess I've covered a little bit about why the card networks want network tokens to be used by everybody. But as a merchant or somebody that's accepting payments, there's really four categories of reason why network tokens are actually valuable. So they help prevent soft declines, which are basically when an issuer rejects a legitimate transaction, even if the customer is intending to pay and it's it's non-fraudulent. They prevent hard declines where the card itself is not valid. They help combat fraud, and they also reduce customer friction. So this is all the stuff that you see in the marketing materials from the card networks themselves. I think the challenge is if you go reading on, you use an LLM of your choice, or you go reading blog posts online, there's very little detail about how it actually helps solve them. So we're trying to kind of dive a little bit deeper and kind of remove the marketing buzzwords from the reality of how network tokens actually help. So in the first topic of soft declines, like I mentioned, soft declines are when an issuer rejects a transaction, even if it's seemingly legitimate. So there's four general decline reasons. There's a few more as well, but do not honor is kind of the infamous decline reason for a payment transaction, where for whatever reason, the issuer just doesn't want to honor the transaction. There's suspected fraud, which is reasonably straightforward. Restricted by issuer rules, which is a bit kind of more niche and doesn't happen as often. And then an even more niche one, which is invalid transaction conditions. So for do not honors, the merchant binding and the fact that there's a cryptogram in place for a network token mean that the issuer is more likely to approve the transaction. And I think part of this is that issuers just have more favorable fraud logic for transactions that happen with network tokens. But a bigger reason is actually when you create a network token from a raw card, the issuer gets to do a risk-based assessment for whether they want to permit provisioning of that network token or not. So effectively, if you create a network token and then you subsequently authorize a payment using that token, the issuer gets two shots on goal to basically decide if this transaction is legitimate or not. So even though in some cases you might see failure to create the network token, you're more likely to see success at a later date when you're processing the transaction. From a fraud perspective, the tokens also prove the origin of the token itself. So the merchant has had the card on file for X weeks or X months before authorizing this transaction. It's not a brand new PAN that a user just typed in, and they just have more historical data on that token to go off when making a routing decision or an authorization decision. Issuer rules. So is this token allowed to be processed by this particular merchant? The token itself is merchant specific. So you get a deterministic guaranteed overview on whether the token itself should be used for this transaction. And then for invalid transaction conditions, the tokens themselves just have richer metadata. Like I mentioned, they have information about when the token was created and not just when the payment is happening. And then so for any risk rules on, have we seen this card before, or is this sort of an abnormal purchase for this particular card? They just have more historical data to go off specifically for this merchant rather than aggregating data across all of the merchants that a particular issuer might be authorizing transactions for. Soft declines, I think, are the one that I guess frustrate merchants the most because it's very hard to dig into why it's happening in the first place. But network tokens definitely help a lot here. Not as much as they do with hard declines, which I'll cover here in a second. So hard declines, like I mentioned, are basically when you authorize a transaction, but the underlying card is invalid. Either it's expired or for whatever reason, the card number itself can't be used to authorize a transaction. This is where the majority of the auth rate uplift for network tokens comes from. The stuff I spoke about before around kind of fraud models and fingerprinting and so on, that helps a little bit. But for the auth rate uplift that the card networks quote that we'll cover in more detail later, the majority of it actually comes from minimizing hard declines, which without using network tokens, you can actually solve using tools like Account Updater. But Account Updater has a lot of drawbacks, which we'll also run through in a few minutes. Because a network token is automatically updated by the issuer anytime the underlying card itself changes, whether that's because of expiry, replacement, if the card is marked as stolen, or if the card is reissued, the issuer will basically send a notification to the card networks or the token service, who then pass that on to the owner of the token. So if you have a network token on file, even if the underlying card is expired and is subsequently reissued by the issuer, the network token itself remains consistent, or at the very least, you're guaranteed to get a fresh update from the card network if the token does change. And then as a result, you'll see a massive reduction in declines for things like expired cards, frozen cards, all this sort of stuff. So this is where the majority of the auth rate uplift comes from. And the nice thing about the lifecycle updates with network tokens is, generally speaking, they're free, versus something like card account updater, where maybe it's 20 cents or 25 cents in certain cases, depending on your PSP. This is like an out-of-the-box authorization improver. That's sort of like a no-brainer if using network tokens is an easy option for you as a business. Fraud and security is what the card networks themselves talk about quite a lot. But in practice, there's kind of three ways that network tokens actually help mitigate fraud and security risks. The first is stolen PANs. So, straightforward example, if a customer makes a purchase at an illegitimate site, their card number and their CVV is stolen, the cardholder might cancel their card. But if a network token was created 6 months before the card was stolen, that network token is actually safe to continue using, because the issuers know that even though the PAN was stolen, that token has existed for 6 months, and you get better guarantees that the card itself the token itself is reflective of a legitimate cardholder who wanted to make a legitimate transaction. It also means that if the cardholder marks the card as stolen, they can cancel network tokens for certain merchants, but not all merchants. And also, a network token, even though it looks and feels like a regular credit card number, typically in a checkout page or a payment iframe that you might get from a PSP, you might be able to paste in the network token, and sometimes the PSP will accept that as a card number, but you don't get a CVV. So network tokens use cryptograms, which are much longer alphanumeric and special character strings that represent a security value like a CVV. But if you steal card or network tokens from a merchant who has some sort of security vulnerability, you can't just take that network token and make a purchase on Amazon or some other merchant. So there's a lot of nice guarantees there. The second thing is replay attacks. So if there's some other service provider that intercepts a particular payment transaction somehow, whether that's a payment gateway or some other service provider, the cryptograms that you use to authenticate a network token transaction are cryptographically bound, but more importantly, they're single use. So once a network token transaction has been processed using a cryptogram, that cryptogram can't be used again. So you can't repeat the same purchase multiple times. Whereas with a CVV, that's obviously static unless you reissue the card. So reuse of network token transactions across multiple merchants or even the same merchant, generally speaking, is impossible. And then the third is just a prevention in general, kind of account takeover and card on file abuse attacks. Because the underlying PAN is never stored by the merchant, the token can be revoked really, really quickly, where it can be isolated just to a particular merchant that's known to have a breach, rather than freezing the entire card outright as well. And there's a little bit of nuance around some of these points, but generally speaking, because the tokens are merchant bound and they're domain bound, as in it can only be used for e-commerce or it can only be used for subscription payments or something similar, you just get much better guarantees and controls around this card or this token only being used for the use case it was intended for when the token was created. And then finally, friction. Friction is a major piece. And I think network tokens aren't the only solution here, but if you've got a card on file or recurring subscription business where the user puts in their card once, and then you're authorizing a payment every month or every few weeks or whatever the cadence looks like, it means that your transactions can just continue processing for the same card for much longer. You don't need to prompt users to re-enter their card details when they expire. The networks will just automatically send notifications to you as a merchant via your service provider with the fresh credentials. So it means that the lifetime value of your customers is much higher. And also customers just don't need to go through the pain of re-entering their card details, even if they intend on continuing with a particular service that they're using, whether that's a streaming service or maybe it's just a merchant that they frequent online and they want to keep their card details on file. As I go through the presentation as well, there is a questions tab here in the webinar platform, so feel free to shoot and we'll get to them at the end in the Q&A section. One thing as well is not every merchant is going to get as much value from network tokens as other merchants might. I've covered the kind of card and file and recurring use cases a little bit in the past couple of minutes, but if you don't have a card and file use case and most of your transactions are guest checkout, you will get some auth rate uplift, but definitely nothing close to what the schemes actually talk about. So the primary use case for network tokens is for anybody that needs to maintain the cards on file for a prolonged period of time, which for a merchant, in many cases, if it's just a one-off purchase and you don't care too much about repeat purchases or loyalty programs or anything, you're not going to get as much value. But if you're a service provider that's serving many merchants, or you know that your merchant is going to want to charge that card again in the future, it might make sense to create a network token for every card that you collect. As we've spoken to merchants over the last couple of years about network tokens, I think one of the things that comes up a lot that's kind of somewhat true, but maybe kind of overstated a little bit, is issuer adoption and issuer support. So we have the luxury of having data on network token creations across pretty much every country, every merchant category, and so on. So what we found is actually quite promising. So globally, out of all of our transactions in the past few months, 89.9% of all token create attempts are supported by the issuers. So that doesn't mean that the issuer doesn't decline the network token creation event. It just means that 10.1% of all of the attempts that we've seen are just end up failing because the issuer doesn't support them. So this doesn't necessarily mean that 90% of issuers do support network tokens. It means that 90% of volume is supported by issuers. So for example, there's a long tail of very small banks that don't support network tokens, but the majority of major issuers in most countries who make up the vast majority of the volume, they do support it. So in general, if you're creating network tokens for 100 different cards that are reflective of the typical kind of customer concentration that you see, you should see about a 90% success rate on issuer support, minus a few percentage points for declined tokenizations, whether that's the cards marked as stolen or just for whatever reason the issuer thinks it's pretty risky. So we created a little map here just to show you what issuer support looks like. Everything marked in red is a country where we haven't seen successful network token creation events, but only on the major schemes. So this is for Visa and MasterCard primarily. If you look at China and Russia, for example, this doesn't include schemes like UnionPay or Mirror in Russia, for example. So for Visa and MasterCard, support in pretty much every country that you might be processing Visa and MasterCard volume in is generally quite good. But there's a list here of countries that we haven't seen successful requests for. Typically, they're either very small countries or for whatever reason, they're just not well integrated with the kind of global payment rails. So with all of that in mind, there's kind of 4 points that I recommend taking away when you're thinking about implementing network tokens. The first is, even though issuer support is really good for network tokens, you do need to plan for PAN fallback. So if 90% of your requests to create a network token are successful, the other 10%, you obviously don't want to just miss out on that business. So you are going to need a PAN failover strategy. Typically, if you're using a token service provider or a token vault, they'll allow you to store both the network token and a token representing the raw PAN. You'll need that, especially if you want to have retry strategies and so on, where you try initially with the network token and then fall back to the PAN. You're always just going to want to replicate both the network token and the PAN if possible, and then just aim to use the network token initially for pretty much every transaction. So then for those cards where you are not able to create a network token, we also recommend using services like Hard Account Updater, preferably real-time account updater, where you can basically get fresh credentials every time the card is ready for authorization, but it's expired or stolen or something similar. That way, across 100% of your cards, or at least the vast majority of your cards, where either network tokens or account updater are supported, you can continue on charging and authorizing a card, even if the underlying card details have changed. Thirdly, robust fallback and writing logic. I think this is a very difficult thing for a lot of companies to manage. In many cases, your PSP will do this for you, but if you're a large merchant or you have a sophisticated use case, or maybe you're a PSP yourself, a lot of your engineering resources are going to go towards basically building retry logic. And there's a lot of optimizations you can make using fancy tooling like predictive models for whether a network token or a PAN is going to be more successful. The kind of 80-20 version of this is basically always try the network token and then fall back to the PAN. because after that, there's only so much you can do. You're not really, you're not able to just keep retrying the payment many times in quick succession. If it's a subscription business, you might get away with that. But for anything guest checkout where the user is actually in the purchase flow, you don't want the latency for a particular transaction to be multiple seconds or even longer. And then the fourth is these numbers are changing all the time. So the schemes have been mandating network tokens for quite a while in most countries, since 2018 in the case of Visa. So these numbers are creeping up. If you're serving maybe some of the countries that don't have issuer support that's as good, that might be true today, but in 6 months' time, that could totally change as well. So unfortunately, there's no particularly good public data on this, and a lot of the kind of marketing collateral that's published is years or multiple years old. So we have real-time data on this. If anybody's interested in learning more about issuer or acquirer support for network tokens, I definitely recommend getting in touch. So that's pretty much everything on the kind of adoption side of network tokens. With all of those sort of factors in mind, I think an important thing for a business that's making a decision on whether they want to use network tokens is just putting numbers on it. So how do you actually calculate the ROI based on all of these factors? So we'll start off with some blended performance benchmarks that are both quoted by the card networks and also data that we've seen firsthand. So Visa quotes a 4.6% uplift in authorization rates for network token transactions versus raw PAN transactions, as well as a 40% reduction in fraud. MasterCard, on the other hand, they quote a lower auth rate uplift, but a higher fraud reduction. Like I mentioned, the majority of the auth rate uplift tends to come from minimizing hard declines. I don't know exactly why MasterCard's quota number is a bit lower. There's a few theories there. Maybe MasterCard has a higher prevalence with potentially neobanks or maybe some of the services that are using or issuing MasterCard cards are more focused on virtual cards or short-term use. So they just have fewer expired cards. But regardless, if you take a global average card mix between Visa and MasterCard of about a 60-40 split, the blended numbers are a 3.96% authorization rate uplift versus raw PANs, and then a 44% reduction in fraud based on all of the kind of merchant restrictions, and then also liability shift in many cases for transactions that are authenticated using a network token cryptogram. So the first step in calculating the ROI is figuring out your revenue uplift. And in many cases, like a lot of the kind of variables here are pretty basic arithmetic, but it is useful to just break it down. So if we take a typical merchant, let's say they're doing 100,000 transactions a month, their average basket size is about $50, and currently they've got an authorization rate of 90%. If you kind of multiply all those numbers out, you'll see about 178K in revenue uplift just from using network tokens. So, versus $5 million a month, it's pretty material, especially if a company's focused on top line growth above all the other kind of below the line points that they might care about as a business. The second piece is fraud savings. This is relatively smaller, but for a merchant with a 1% fraud rate, that's on the higher end, admittedly. Maybe you'll see this in categories like travel or iGaming or something similar. But if 1% of your transactions are charged back, unfortunately, many of the major PSPs will just kind of boot you off their platform. But if a business does have a chargeback rate around that, and the chargeback fee is about 25% of the transaction value, this is a rough estimate based on the actual scheme and bank fees for processing a chargeback, as well as the likelihood that you lose that chargeback and end up having to pay the money back. We're kind of conservatively estimating this around 27.5K a month for this merchant that's processing 100,000 transactions a month and $5 million a month in actual volume. The third piece, which we didn't really cover, is fee savings. A lot of merchants aren't going to care too much about this, primarily because if they've got a high margin product, the few basis points on network fees is not the biggest deal. But if you've got a high volume or low margin, or maybe some combination of both style of business, typically you'll see about a 10 basis point reduction in interchange fees and scheme fees. That's because Visa has this secure credential framework fee. MasterCard has an equivalent as well, but these are basically extra levies that are placed on transactions that don't either use 3D Secure or network tokens. So you will save a little bit of network fees as well. So again, in this case, for the 100,000 transactions a month, you'll see about 5K in cost savings as well. And then kind of pulling all of this together, one of the things we didn't cover is how much do network tokens cost? Typically from a PSP, in many cases, they'll massively mark up the fees for creating network tokens. We've seen fees as high as 25 cents or even 50 cents. For anybody that's provisioning a scale with a dedicated token service provider or something similar, you'll see something around 1 cent to 3 cent maybe for provisioning network tokens, depending on your volumes. In comparison to card account updater, which is about 20 or 25 cents for each card update, it's a pretty material improvement. So would definitely recommend taking a look at network tokens if you're a heavy user of card account updater already. This is obviously a reasonably clunky formula, but for this merchant that's seeing 100,000 transactions a month with a $50 basket size, the total ROI on a monthly basis for this merchant is about 209K. So pretty material. I mean, that's 4% ish or 4% overall improvement on payment performance, which is kind of like a free month of growth for any fast growing business that's targeting kind of 2x year on year or something, just from improving your payment performance. So it's pretty nice. There's a few caveats I'll call out when calculating ROI, and also a few mistakes that companies tend to make. The first is starting with an accurate baseline. I think, especially for payment teams that are relying on, I would say, more modern PSPs, they kind of think it's a great idea. They want to start using network tokens, and they might be using a modern PSP like Stripe, Adyen, Checkout, or something similar. And they don't actually realize they're using network tokens already onto the HUD. They might even be charging you for it. But a company might start off with one of these PSPs. They layer in additional infrastructure like us or some other kind of token service provider, and they don't see much benefit because they're comparing network tokens versus network tokens. And in some cases, you might even see a slight decline because the PSP might have better insight into your overall payment performance and some of the updates they can make there. The other risk is you can also undermeasure. So if you do see an improvement, the actual improvement versus raw pan processing could be way higher than you actually expect. So we see a lot of merchants who start off and they're maybe a little bit jaded because they did a massive project, spent a load of money, invested a load of engineering resources, and they just haven't seen much benefit. So like I mentioned, because the majority of the gain, so out of the 3.96% auth rate uplift that you see from network tokens on average, about 2.5% of that gain, so 2.5 points, so about 2/3-ish or even more of that transaction uplift typically comes from reducing hard declines. And most of that comes from the lifecycle management as well. So if you kind of think through that from the basics, on day one, most of your cards are probably going to be fresh. So if you've just started off or most of the cards this month are fresh, you won't see the majority of the gain straight away because there hasn't been enough time for that card database effectively to mature. None of the cards are expired yet, and they're fresh. After about 3 months, you will start seeing improvements. On average, about 30% of cards are reissued, expired, or marked as stolen every year. And that's the metric they quote for services like card account updater. So working backwards from that, you typically start to see an uplift after 3 to 6 months because those hard declines start being prevented from the lifecycle management events as well. I know there's quite a few questions in here that we will get to later as well. I'll make sure we have enough time as well. So all this in mind, if you run the ROI calculations and you think it actually makes sense, how do you actually go about using network tokens? So there's kind of 3 different ways of doing it. The first is using your PSP. This is the easiest in many cases. Using a standalone provider like us or like maybe a payment gateway or something similar. Or the third kind of more extreme advanced example is building your own in-house solution with direct integrations to the card networks. Option 3 is very rare. It's typically only possible if you're one of the largest merchants in the world. The card networks tend to gatekeep these services, but it's also a major investment as well. And we'll cover some of the pros and cons shortly. We think there's kind of 6 important factors and then many more less important factors that you need to consider when you're picking what way you want to go about this. The first is token portability. So if you create a network token with the provider, can you use them with another provider? In many cases, the answer to this is no. The second is TRID ownership. So when you create a network token, the network token itself is bound to a specific token requester ID, which is similar to a merchant ID, but not quite. It's actually just a grouping of network tokens with specific rules. The third is routing control. So if you create a network token, can you actually decide whether a PAN is used or whether a network token is used for a particular transaction? Visibility and reporting. So once you've started using network tokens, can you actually see if there's a clear uplift beyond just a potentially biased graph from your PSP that always looks green for some reason? Cost, as always, and then compliance and regulatory readiness. So if a customer sends a data subject access request or deletion request or something, do you actually have the ability to deprovision that token at the scheme level as well? So option A, like I mentioned, is using your PSP. The pros here is very fast. In a lot of cases, you might actually already be using them, or if not, maybe worst case scenario, you need to either click a button in the dashboard or submit a support ticket with your PSP and they can just turn it on. Not all PSPs support network tokens, especially outside of the kind of major neo PSPs. So it's definitely worth factoring that in. And then the second is automated decisions. So because the PSP is the one deciding when to apply a network token and when to apply a PAN, typically it just saves a lot of engineering effort to actually build that model, build that logic on trying a network token and then falling back to a PAN. So it's definitely the easiest to get started. It does have a lot of cons though. The biggest one that we see merchants with a lot of cards on file getting stung by is that there's no portability and basically no ownership of the tokens. In many cases, the tokens are actually issued by the PSP under their TRID. So you don't own the tokens. If you want to migrate at a later date, you just can't in many cases. And even if you want to pay them, they just can't because it sits under a PayFax TRID or something, and they just don't want to give you access to them. The second is visibility and control. You don't really know when a network token was used, even in the advanced reporting sheets that you might get every quarter or every month from your PSP. It's hard to tell whether a token was used in that case. You don't get performance data. Well, you don't get solid performance data in most cases. Generally, it'll just quote in your QBR, a 2% auth rate uplift, and then they'll expect you to renew at much higher prices than the previous year. And then if you work at multiple PSPs, this is typically where you can get stung the most, where a card might be collected with PSP A, they provision the network token, and then if you want to process the transaction at a later date with PSP B, because you don't have access to the network token from PSP A, you can't move the network tokens around. So you either end up re-provisioning the network token a second time, and then paying multiple times, having a very complicated setup with multiple TRIDs and multiple tokens for a given card holder. And that just introduces a lot of, I guess, sour taste, especially if a company is already using multiple PSPs or they think they might be in the near future. So this is definitely the best for a merchant who does plan on staying with one PSP. And if you just want simplicity and a quick win, it's an easy way to see the metrics go up just by using your existing PSP. And in most cases, you don't even need any engineering resources. The second option is to use something standalone. So this is a service like Evervault or payment gateway that offers standalone network token provisioning. The pros here are TRID ownership. So the token requester ID is yours. The tokens are yours as well. And once you create the token, you can store that on your side. Even if your token service provider is unavailable or you want to migrate away at a later date, you have full control over those tokens. So you can really send them anywhere. On routing control, you can pick where you want to send the transaction to. So you full input on whether a token is used or whether a PAN is used. So if you want to have an experiment where you're trying out network tokens for every single request, you got to guarantee that the network token was always used, as well as the visibility on that at a later date. So you can build very sophisticated data visualizations and pipe that into your BI tooling to track whether the improvements are actually real. And then finally, cost efficiency. So if you're going to be paying each of your PSPs and if you're using multiple PSPs and you're going to be paying each of them to create a network token, if you just have one provider for network tokens, you're only paying once, and you also just get you get a better experience because that provider is just doing one thing for you, and they're more likely to, generally speaking, do a better job of it beyond just your kind of holistic payments experience. The con here is that it's one more provider. You do have to integrate another service into your stack. You need to make sure they have the ability to get access to the raw PAN to actually create that network token. So it does require engineering resources, whereas using a PSP doesn't, at least in most cases. So this is generally best for merchants who have some engineering resources, but they also want to use multiple PSPs. If you operate recurring or subscription models, you might decide you want to do this from day one. Or also if you just want control, even if that's future proofing, this is a very good choice. And obviously we're biased, but this is intentionally option B, which is right in the middle of the three. Option 3 is a standalone solution directly integrated with the card networks. So this is, as I mentioned, generally speaking, not available to anybody other than the largest merchants in the world. So if you're a Netflix or Amazon or something, they will open up access. If you're big enough and well kind of connected enough to the networks that you can get access to this, it is very compelling. The two pros here are that you have direct integrations, so you still own the TRID, you have maximum control, and because you're integrated directly to the card networks without any middlemen or intermediaries, you get much lower latency as well. So if you really care about performance and infrastructure availability and so on, this is a good choice. The second is cost. So if you are operating at the scale integration with each of the card networks and build them separately, there's no token fees, generally speaking. There are kind of major fees on certification and integrations and so on, but once you're integrated and you're sending transactions through, each marginal network token, generally speaking, doesn't cost you anything, which is pretty nice, especially at massive scale. There are a lot of cons here. So the first is just the operational overhead. Each card network has its own separate token service. So you have to build separate integrations. You have to recertify every year. You basically need a dedicated payments engineering team that's building and maintaining all these integrations. So on the ROI calculation, it becomes a lot more complicated, where you have the kind of marginal ROI, but you also have a fixed cost of probably millions per year in actually maintaining these integrations. The second is compliance. There's no way around being PCI compliant if you want to build these integrations with the card networks, and you're going to be handling raw PANs. So that's incremental cost. Accessibility is a big challenge that, again, if you're a big merchant, you can potentially kind of wave your big stick. And then the fourth is ongoing maintenance. So as the card networks update their schemas or they add new features, and then also some of the error messages that you get back from both the token services and the issuers, they're all different across each of the token services. So you have to kind of build all these mappings for different response codes into a kind of normalized structure if you want the ability to have clean data as well. So this is the best for very large merchants or maybe very large PSPs who have the ability to build these integrations. And then they also have the appetite to kind of treat network tokenization as basically a core part of their product. So it does make sense if your core product is payments and you have the ability to do it. But I'd definitely be wary of doing it. I mean, from experience on our end, it's not easy. So in summary, there's a table here. I've kind of run through all of this already, and I'm not just going to kind of reiterate it, but it might be useful to just either screenshot this, and the recording as well as the slides will be available to anybody after this webinar as well. So that's pretty much the end of the structured content. I know there's been quite a few questions here that we can run through now in the Q&A, but thank you to everybody for joining. So one question on fraud. Merchants mostly care about fraud chargeback rates, and especially because of Visa and MasterCard fraud programs, I guess, like VAMP. Does the fraud rate reduction promoted by network tokens address the issue? So yes, in many cases when you are processing transaction using network tokens and you have a cryptogram, they in many cases will give you an ECI value back, which gives you liability shift in much the same way as a 3D secure authentication does. So if you're looking at things like VAMP ratio, where you've got TC15s and TC40s, you will see a major reduction in TC15s just because there'll be fewer fraud initiated chargebacks because the liability remains with the issuer as well. Another question from Errol: if network token creation and cryptogram generation are successful, can we assume the auth will be approved? No, is the short answer. So network token creation and cryptogram creation only have context on a particular credential with a particular merchant. When you're creating a cryptogram for a network token, generally speaking, you're not passing in any context around how much the transaction is for, when the transaction is actually going to happen. So you will see an increase in authorization lift, but if somebody wants to make a $100,000 purchase and they've only got a $1,000 credit limit, you don't get any of that context as part of the network token creation. So when you move forward to payment authorization, there's a correlation between network token success and payment authorization success. But you don't always, you won't be able to block outright, insufficient funds or errors like that. Another question from Trevor is, we tried network tokens for a while, but didn't see much uplift. Why do you think that is? This is an interesting one. I think, like I mentioned, a lot of merchants are, there's sort of two reasons for it. In some cases, it's just the impatience point, because most of the auth rate uplift is from merchants who, or is from the kind of hard decline reduction where the card expires. They just haven't waited long enough to see cards actually come to maturity, be reissued, and then the corresponding drop in auth rates if you're not using network tokens versus if you are using network tokens, you see the uplift. So part of it's patience. The other part is, in many cases, you might be coming from a scenario where your PSP is already performing network tokenization for you. So you don't necessarily have clean data that you're actually comparing it against. So make sure that your PSP isn't using network tokens if you are doing an analysis for it. But that's sort of the likely scenario here. Are network tokens supported within Visa's compelling evidence 3 framework? So compelling evidence is very explicit about the requirements for it. I'm just trying to jog my memory on exactly what it is, but I think it's there's like 2 identifying factors, whether that's IP address or maybe billing address or something similar, that have been consistent across, maybe it's 6 months or something like that. There's no specific carve-outs for using network tokens with compelling evidence. So compelling evidence would be one way of eliminating the chargeback, but with network tokens, you'll get the liability shift as part of the EMV liability shift. So it mightn't even get to the point that there is a chargeback in the first place. If it's a chargeback for merchandise not received or something similar, compelling evidence won't allow that anyway, but compelling evidence is mostly useful for unauthenticated payments, either via network tokens or 3DS. Question from Andrew. For a large merchant that generally has low card on file repeat customers, do you have any estimate on the typical authorization rate uplift? I guess it depends on what you mean by low. Assuming that 100% of your transactions are one time or the cards have been collected, it's in the ballpark of like 30 to 50 basis points. So pretty material. And most of that increase isn't going to come from hard declines, unless maybe the customer has the key or their wallet in their web browser has their expired card that gets pasted in, and then the network token is issued based on the newer credentials. That might give some amount of uplift, but it's basically the soft decline portion of the auth rate uplift. So kind of 0.3 to 0.5%. Another question from Errol. If we got a cryptogram and then the auth was then declined, is there any point retrying with a PAN? There is. It does depend on the decline reason. So again, if it's something like insufficient funds, you're probably just wasting energy and also cost as well, because you'll have excessive retry fees and so on. If it's a soft decline, so you still can get things like do not honor or something similar. If that's the kind of decline code that you do get back, there is definitely a point retrying with a PAN, just because you get more guarantees that the cardholder was present, especially if you use the CVV. But if it's a card on file use case where you're doing a recurring payment or something, you won't have the CVV, or you shouldn't have the CVV, because those can't be stored after the initial payment authorization. So for a merchant with 3 PSPs and 1 standalone vault provider, we're evaluating a standalone network tokenization solution. This requires coupling with their system in the payment flow, which may raise concerns about redundancy and incident handling. As a standalone provider, what's your view? One thing, so I guess there's 2 parts. The first is actually evaluating availability and resiliency as part of finding a provider. So I'd be looking for things like active-active mean, the US East 1 incident in AWS last week is a prime example of how this can go wrong. And just general kind of infrastructure product procurement is something to think about. The second piece is, even if you've got the most resilient vendor and you trust them and you know everything's going to go well, you should still just build your system assuming that not all the critical components will be available at any point in time. The nice thing about network tokens is they're fully out of scope from PCI. So at the point that you're creating the token, because you've just received the raw PAN, the token service provider does need to be available to create the network token for you. But for any subsequent payments where you have the token on file, they're not necessarily in the critical path because you have the network token. Even if you don't have the ability to call the token service provider to create a cryptogram, you can still do an MIT with that transaction without a cryptogram. So cryptograms are only, like, you can use them for MITs or recurring payments, but you only need to do them for customer initiated transactions where the user actually clicks buy or something similar. So in that case, your token service provider doesn't need to be available. You just need to make sure that the network token is actually stored on your side, which thankfully you're allowed to do with network tokens. But yeah, I mean, I'm more than happy to talk to you as well. We deploy everything multi-region active, and yeah, it's something that we really care a lot about, especially for kind of high volume service providers and merchants. But yeah, I think that's pretty much everything. Really appreciate everybody joining. I know there's a poll that's just popped up. I'm more than happy to speak with anybody if you've any questions about network tokens or card processing otherwise. But other than that, thanks for joining and enjoy the rest of your day.